All right, let's pull back the curtain on a system you probably use every single day, but maybe don't fully understand, the Facebook Newsfeed. We're going to get into the nuts and bolts of the complex architecture that decides what you see, and just as importantly, what you don't.
So let's just kick things off with a pretty wild idea, and this comes directly from the engineers who actually built it. What you're looking at, it isn't really a feed. You know, if you're picturing a simple chronological list of posts, you're kind of missing the whole picture of how this thing is designed.
A better way to think about it is as a screamingly fast, real-time optimization engine. Its one and only job is to constantly figure out the absolute best thing to show you next, and it has to do it in milliseconds. It's an entire system built to solve one massive, fundamental problem.
And that huge problem? It's all about scarcity. But not a scarcity of content, no. It's a scarcity of your attention. There's a practically infinite amount of stuff you could see, but you only have so much time in a day.
Think about it. Every single time you open the app, there are literally thousands of potential posts from your friends and pages just waiting there, but you're only going to see a handful of them. So the system's whole reason for existing is to sift through that mountain of content and pick out the very best few for you.
So way back in the day, the original mental model for this was a really simple but powerful formula called EdgeRank. And even though things are way more complex now, this idea still gets at the core of what really matters. It was all about balancing three key things.
First up, affinity. This is basically how close are you to the person who posted this, right? A post from your best friend is obviously going to matter more to you than one from some random page you liked 5 years ago and forgot about.
Next, there's weight. And this is super important. Not all interactions are created equal. A thoughtful comment, that takes effort. That shows way more interest than just a mindless scroll and like. The system knows this and weighs them differently.
And finally, time decay. This one's pretty obvious, right? Content gets stale fast. Nobody wants to see last week's news at the top of their feed. So the older a post is, the more its score decays over time.
Okay, so EdgeRank was the old way. Now we get to the really clever part of how modern systems work. And honestly, this is probably the most important architectural choice they make. It's a two-step process. The first step is candidate generation, and that's all about recall. It's about quickly grabbing everything that might be interesting. The second step is ranking, and that's all about precision, carefully picking the absolute best of the best from that initial.
So what you end up with is this thing called a multi-stage ranking funnel. It sounds complicated, but it's actually a really elegant solution. Let's walk through it step by step.
Okay, so at the very top of the funnel, you've got this just massive inventory of everything you could possibly see. Every single post from every friend, every group, every page, we're talking a fire hose of data. Now, there is no way the system can deeply analyze every single one of those posts. It would take forever and cost a fortune. So stage one is all about being fast and cheap. It uses really simple signals like, is this from a close friend, or did this get a lot of likes recently, to quickly narrow that giant list down to just a few thousand promising candidates. The only goal here is don't miss anything that might be good. Okay, now we bring out the big guns. This is stage two, the expensive part. This is where a heavy-duty machine learning model gets to work on that much smaller, more manageable list. It can look at all sorts of complex features to really score each post and figure out which 50 or 100 you are most likely to care about right now.
And the craziest part? This whole process, this entire pipeline from start to finish, happens in the blink of an eye. Every single time you pull to refresh your feed, all of this is happening in the background just for you.
And this right here, this shows the whole thing perfectly. You can literally see the journey. It starts with this chaotic mess of everything on the left, and as it moves through the funnel, it gets filtered and scored and refined until you're left with that perfectly curated list you see on your phone.
So you might be thinking, a system this huge, this complicated, what happens when something breaks? And trust me, things always break at this scale. Well, it's designed for exactly that. The goal isn't to be perfect, it's to be resilient.
For instance, what if that big, expensive ranking model we just talked about suddenly slows down? Are you just stuck staring at a loading wheel forever? No way. This system is smarter than that. It has fallbacks ready to go. It might instantly switch to a simpler, dumber, but faster model. Or maybe it'll just show you the feed it cached for you a minute ago. The key thing is, you still get a feed. The quality might drop a tiny bit for a moment, but the service doesn't go down.
Okay, so that's a technical failure. But what about a product failure, like the infamous filter bubble? What happens when the algorithm gets stuck in a rut and only shows you the same kind of stuff over and over?
Well, the engineers thought of that too. The system actively fights against this. It has hard rules to enforce diversity. It'll purposefully inject some exploration posts, stuff it's not sure you'll like, just to see what happens. And it's always boasting new stuff to keep things from getting stale.
And this idea, this graceful degradation, it's everywhere in the system. If pretty much any non-essential piece breaks, there's a backup plan. It all boils down to one core philosophy. It's better to have a good enough feed that works than a perfect feed that's broken. Availability is king.
And all of this brings us to what might be the single biggest lesson for anyone building a system like this, the #1 trap to avoid.
It's what they call the principal engineer trap. The temptation to say, I'm smart, I'm going to build one massive, perfect ML model to solve everything. It sounds so clean and elegant on a whiteboard, right? But in the real world, it's a disaster. It just doesn't scale.
So if you take away just one thing from all of this, let it be this. The secret to a great ranking system isn't just about how good it is at picking the winners. The real magic is how smart it is at deciding what not to rank. Being ruthless about what you ignore, that's how you make something like this actually work at scale.